Hello, welcome to the day 4 of system design session. The use case is semantic layer generation using AI agents. So till date, we discussed what is the different process. Because whenever we are considering one use case, we need to find out manually how this use case is getting processed now. Whether some steps are done by human and some steps are getting achieved through the tools available currently in the market. So from there, we have tried to find out which are deterministic. Those steps we should not touch. The ambiguous steps only we need to touch for considering for automation. And from there again, we have gone through 4 questions how to come up with which step should be automated using AI agent, like whether it is reasoning or it is retrieving, and some questions. If you go back to the day 2 sessions, then those set of questions are mentioned, and this was like one kind of home assignment to come up with a set of AI agents. So now let's try to find out which are the, using all this knowledge that we have gained since last 3 days. Now let's come up with what are the different agents can be possible. So the complete process looks like this. Hello, so here we are trying to know the complete process flow. Here in this perspective, if I say here, first is the data sources. So it is like various kinds of data sources available for our application. We are building the semantic layer generation. So there should be some kind of structured data and unstructured data should be getting ingested inside our system, whether that is the object storage, and later it will be processed to the enterprise data platforms. So data sources, and then after that DDL parser. So if you are not aware about what are these steps, then I had already discussed in day 2 session. You can have a revisit of that session. Then metadata. So I am not repeating again explanations of all these steps. Then next is that metadata extractor. Next is about data profiler, and then it is catalog generation, then human semantic expert, then glossary generator, business glossary generation, then it is like human validation, then semantic layer is getting generated, and here again it is like publish the semantic layer. So this was the high level process flow. Some are like human and some are like achieved through some kind of available tools. So through our all this day to how we have to come up with the agent. So what is in your mind that how many agents can be possible here? I'm just writing down here. One is that semantic understanding. And also this is I will give some home assignment for you to design the bounded context, entities, value object, whatever the attributes we had defined yesterday, we had discussed related to domain driven design system. You have to do that. So here semantic understanding, and next is that semantic validation. Next is about semantic reasoning agent, and next is about evolution agent, right? So what are the things all these agents they have to perform? The first one is about semantic understanding. So that means it understands the raw metadata, schema, all this documentation, the process flow, database, sub-process flow, who are the owners and how they are achieving. So it is the complete understanding of the complete flow. and then generates the candidate business concepts and the semantic interpretation of that. What are the different entities, how they are related, how they are getting achieved. So semantic interpretations, relationships, all those are getting achieved here. So this is the complete holistic picture of semantic understanding agent. Then once that is done, whether that is the proposed semantics against the ontology constraints, whether that is how that should be validated. So that can be performed through the semantic validation agent. And while semantic understanding, there should be some kind of proposal that okay, what should be the business rules, what should be the glossary, how should be the schema rules should be defined. By analyzing everything that has been performed through the semantic understanding agent. And this validation agent also determines whether the proposal is valid, invalid, or require further reasoning. Okay, so next one is about the semantic reasoning agent. It handles the genuine ambiguity. Reasoning means it handles the genuine ambiguity. It produces a recommendation with justification, and how it produces, before that one step is that performs multi-hop reasoning across the ontology, knowledge graph, relationship, business context, existing concepts, and the evidence. So these are the three responsibilities of this agent. So we have to very clearly define what is the responsibility of each agent. Then next one is that evolution agent. This is a very important part, how this would be evolved, the complete systems. If a new business domain is coming, without changing any evolution agent, this is an important one, and it looks at how the semantic layer should evolve based on new evidence, raw data, changing business definitions, historical decisions, feedback, and human approval. That means when a new ontology is coming, without changing the agentic AI workflow code, how that a new ontology will be developed, and that should be plugged inside the agentic AI system, so that the routing should happen, okay, based on the user intention. The routing should happen to the respective ontology and the related artifacts, for example knowledge graph and something, and then again it will be following the same steps to perform to complete the agentic AI operations. So it can propose the changes to the existing semantic artifacts rather than treating every generation as a brand new artifact. So these are all the 4 agents we have come up. Now the topic of day 4 is that state graph. So when I say here state graph, so for example, let's understand why LangGraph, StateGraph exists and how to design ours. This is the topic of day 4. So now let's understand, let's put some questions. Okay, I decided that okay, these are the some complete process flow, and inside this, and this complete process flow is divided into these 4 agents. So one agent may have one or multiple responsibilities, definitely. So inside this glossary generation, reasoning, there will be multiple substeps inside that, and those will be performed through some kind of tools. Okay, tool performance and the internal NCP. There are a lot of things we are going to discuss in the future about the complete architectures. Let's understand that if somewhere, whether in this complete thing step 3 fails, or inside this the sub process some step 9 fails, then is there any way to, without looking at the code, and is there any way to know in which step the workflow has failed? What might be the reason of this failure? Does it exactly, if when it fails and gets repairs, does it exactly resume from that step, whether that is the 7th step or the 9th step where it was failed? If you don't know the answer without checking the code, then you don't have a state architecture. You have just a script, and that happens when the workflow is defined, when the workflow is working without any edge case or without any failure scenario. That is a very happy path. When nothing goes wrong, that should work. So all these failure conditions we need to keep in our mind while designing the complete architecture. So in today's session, we designed the state architecture for our semantic layer system properly, and I will explain exactly why the frameworks like LangGraph introduces StateGraph abstraction instead of just letting you pass variables between the function calls. So when we are designing, you must be aware, you must have seen that state graphs means we are passing a set of variables. Okay. So in simple script, state is whatever, let's understand what is state. A state is whatever memory between the function calls, and that's fine for a demo, but it breaks when the moment you need any of these. Any of these means 1, 2, 3, 4, I will tell you. Okay. The first one is about recoverability. If the process crashes, in-memory state is gone. So we have to save that somewhere in the persistent database. How we have to save that in persistent database? If the structure schema state is not defined, what? From where something we will store in the persistent database? No. We have to define that, right? Okay. The second one is that observability. If you cannot inspect, what did the system believe at step N after the fact if it was never persisted? Okay, so we have to persist that. And then auditability. If some architectural principles, it says that, okay, each step, it can be auditable, which requires state to be like the persisted, inspectable thing, not an implementation detail. One is that human in the loop pauses. For example, there is a step N, and the output of that one needs to be reviewed by the human, and the human has to it has to wait for the human review. Human may take 1 hour, may take a longer duration. So till that time, it cannot be saved in the all those actions performed till step N cannot be stored inside that memory. It should be stored somewhere in the persistent database, so that once the human reviews and gives the feedback, then everything will be consolidated in the graph, and then next step N+1 can be initiated. So these are all the reasons why it is not just some variables. There should be information which should be saved inside the persisted DB, so that in case of any error, this complete system should be auditable. Okay, so now let's go next step to understand what is the responsibility of all these agents. So if you are having all these agents, if I say like that, prepare a table. Okay, the table should have all this information, some agent, and then what is the purpose of this? You understood purpose of all these 4 agents. And now what is the input state and what is the output state? Then who is the state owner? State owner, I can say like this, so that it should not create any confusion that these are 2 different columns. Instead, this is a single column. State owner, who can update? Who can update this state? And the next is that who can, the next agent. So the next agent. So if I give examples of our first agent, the first agent is that what is, sorry, the first is our semantic understanding agent, right? And what's its purpose? Its purpose is to understand the schema, metadata, business rules, metrics, documents, process flow, DB schema, everything, right? So that you have to fill up. And what is the input for this? What is the input to understand? Raw data, raw metadata, process flow diagram, schema, context, documentations, set of retrieved glossaries, what are the different ontology context, process flow diagram, business rules, business entities, what is that, KPIs, everything. Those should be the input state. And what is the output state of that one? It is like semantic candidates. Okay, these are some entity. What are the semantic candidates? What are the entities candidates? Proposed glossary terms. Understanding the confidence provenance. So these are some output state. And then the state, okay, these are some output state, and the next is that the state owner. So this has become state owner. Who is the state owner? The same agent should be the state owner. Remember that while we are designing, the same owner should be the state owner. Who can update? Same agent only can update, and this is the bounded context we had defined. No other can. So because of that reason only, we'll be able to trace that, okay, failure has happened in this case. So this is the owner, and this agent can only update this one. And the next agent will be, what is next agent? We had run here. It's the validation, semantic validation agent. So next agent, you just write down this table and prepare for all the agents. This is the homework for you tomorrow. Now let's understand what are the complete graph state. Okay, so here what happens, when we are building this in the systems, there should be some kind of context, system context should be there, session context. For example, what is the session ID, who are the tenant, who is the user, and some kind of input, and also some kind of other. Then these agents will be starting. Input means, see, when we are building this, then there should be some kind of user interface that we have not come yet. So that is in our plan also. So how to design what is the user input, user interface, and what kind of input should be provided from there. So those will be coming as the input context. So what I will add here, the first one is that session context. So you just remember that this should be the naming convention. The first letters that should be capital corresponding to this. So here what happens, session context, then input context, then next one is about planner. So whether that is required for not, any semantic generation is required or not. Okay, then semantic understanding, I'm just writing SU agent. Okay, and then next is that semantic validation agent. You can write out semantic understanding, the complete word, and then semantic reasoning SR, right, and then agent, and then evolution agent. Okay, and then output state. This output state should be, it should be published. Okay, then audit, then publish, right, audit state. That publish is a step only, so that is not like a separate agent here. So always keep in mind, this would be the naming convention like this. Okay, so here for each of these, you already know that what are the functionalities of all these agent context. So fill up the above table for all of these agents, so that it will be easy to understand how you are defining a DDD level design, right? That yesterday we had discussed. So next one is that here for session context, what is the variable should be inside that one? How we have to define this? Whenever you are considering a LangGraph based automated workflow, we are trying to understand what is the manual step, how those steps can be, how the complete process can be divided into sub-steps, and what is the input to each sub-step, what is the output to each sub-step, and then merging everything together, and we are removing the duplicates. So from that perspective, if I say that, I will just give example of the session context, and that is your homeworks. Number 2, to fill up what will be the variables and what are the data types, purpose of each variable coming inside this session, coming inside each state. Okay, for this session state, what I can say is that session ID, then tenant ID, then workflow ID, then workflow version, then what is that? Then I can say started at, updated at, environment, status. Status means whether that is running, completed, failed or paused, and any kind of correlation ID. That means for distribution testing, distribution tracing. So for all of this state, what you have to do? So here what I can say, created at, then updated, created, started at, updated at, status, then environment, correlation ID, and environment correlation ID. Okay, and I have given only for the context, session context. Your job is to complete one table with all. So created at, updated at, status, environment, correlation ID. So I gave examples of all these input variables for session context state. You have this assignment number 2, that you have to complete all the variables for rest of the states with a table. That variables, what are the different variables, what are the data type, and what is the purpose of each variables. Now checkpoint. A checkpoint is a durable snapshot of the full graph state plus whatever output state existed at that point. So taken after every node completes. When node, for example, fifth node fails, so orchestrator does not need to guess what happened. It reads the last successful checkpoint, which tells it exactly which node completed last and what the state was. Then it resumes from the node 5, not node 1. So vested LLM calls no duplicate work and criticality no risks of a non-idempotent side effect. Okay, so this is also what makes exactly once idempotent execution. One of our then we have to also come up with some kind of functional requirement and non-functional requirements from here. So one of our reliability non-functional requirements is that actually achievable rather than aspirational. Okay, so idempotency is not free. Each node feed needs an idempotency key derived from the checkpoint. So rerunning node 5 after a crash produces the same result as if it had never been interrupted. So what happens now? How this checkpoint happens? After every node the checkpoint happens. So here all these, when we are saying like that, these are the states. So these are all the nodes in the graph: session context, input context, planner context. These are all kind of nodes. So after each node there will be one kind of checkpoint. So for example, in SP agent there some crash happens. That means till SU agent, that is the semantic understanding, everything has been saved, and then from the semantic understanding, after the failure recover from the failure, then it will start from the semantic understanding node. And other is that state versioning. So there is one more layer here that most state architecture discussion skips, that the state schema itself changes over time as you add capability. Okay, so these are all the state schema that we have defined. If these are not fixed, as we keep on adding, these will be getting updated. Okay, so if you add a new field in the semantic understanding agent, for example, okay, so that aggregates 6 months from now. So what happens to the checkpoint that where taken under the old schema? The answer is that every checkpoint needs a schema version tag, and your resume logic needs to handle reading an older version checkpoint and migrating it forward. So the same discipline we will apply to the database migration. Similarly, we have to achieve this. Okay. So in today's session, we learned about how to come up with a state design and the state graph design in order to proceed our AI agent implementation with LangGraph. And then I have also given two homework for you. Try to do that one so that it will be easy for you to understand how the DDD should be implemented, how this complete AI architecture should be implemented with the DDD principles, that is domain driven design principles, and again the event driven architecture that is based on that one. So in tomorrow's session, from a single workflow, we will zoom out to how the internal single workflow's internal state, how the multiple workflows and services talk to each other across the complete platforms. Okay, and that is the event architectures. So why AI workflows should be event driven rather than tightly coupled request and response chains, how Kafka fits in, because Kafka is based on the event in streaming informations, and what replay actually buys you operationally, and especially when an ontology gets updated, and how to re-evaluate the complete systems end to end, how to know that where the actual failure has happened and which artifacts are updated, where the complete observability, and whether output from one state is moving to the other state, how we can validate that everything is correct, input output those are in sync. These are technical terms are that Pyrentics is there for the validations, but all these informations that we are going to discuss tomorrow. So stay tuned and try to complete 2 assignments. Thank you. See you tomorrow.